One more presentation before a break. Always an interesting category. There's production, energy and logistics. This is a SPP Central Control Building in Turkey. Please welcome Bijin Architects. Welcome.
Hello. I'm Caner Bilgin, co-founder of Bilgin Architects, Istanbul. Today I'm here with my wife and company partner Begim, and we are really honored to present our work today. So the story begins in a very unique place in Turkey. Turkey's one and only desert region, Karapınar, which is the closest city to Karapınar is Konya, which is about an hour and a 2-hour drive away from there. So here, if you get closer, you can see the boundaries of Karapınar. It's a small city with a population of 55,000. To the north, there used to be a lake in the 80s. Over the years, due to climate change and intensive agriculture, the lake dried up, and this area transformed into Turkey's only desert landscape. This land is now unsuitable for agriculture, and recently the government designated this area for solar power. And Kalyon Energy developed a 1,350 megawatt power solar plant there, which is more than enough for 2 million people for about a year. It's the largest one in Turkey and ranks among the world's top 10. So if we get closer to the site, the site covers an area of 13 kilometers by 2 kilometers. And to help to visualize this scale, we can compare it with the areas like Manhattan Island, or of course, Singapore City. To see our design, we need to zoom in much closer. During the plant's construction, Kalyon Energy announced a national competition to design the central control and management building. They also wanted the building to accommodate national and international events, and we won the competition with our proposal Oasis. We aim to design a comfortable space for workers and visitors in this challenging environment, engaging with its surroundings and carefully managing energy use. Construction took 2 years, and the building opened in September 2023. We knew it will be challenging to build in this geography, so we tried to minimize on-site construction as much as possible. And we used each material exactly where it will perform best and at the right amount, neither more nor less. We already knew the soil was weak, so the building stands on 86 friction piles with an elevated concrete foundation. Above this level, we used prefabricated steel elements. And we designed a semi-buried partial basement floor for technical rooms. And on top of this is basically a 50 by 50 meter prism divided diagonally into private and semi-private areas. Above you will find the engineering rooms, meeting rooms, and the brain of the plant, the SCADA room. And below there is a foyer, cafe, and a multi-purpose hall. At the very center of the project, you will find the courtyard with a lush landscape, both dividing the zones but also connecting them. At the roof, there is a green terrace offering a 360-degree panoramic view of this solar plant. And due to the regulations, the electricity generated at this plant cannot be connected directly to the building itself. It needs to be all connected to the state grid. So we focused on to maximize the building's efficiency. So what we did about that, we have a double facade to control the sun radiation. And also we use some more PV panels. We achieve a natural cross ventilation. We use high efficiency heating and cooling systems. We collect rainwater wherever we can, and we store it and reuse for the landscaping. And also the courtyard acts as a shade for the building itself in summertime, and in winter, when the leaves gone, it will help for the heating. And the green roof acts as a great isolation for a one-story building at that climate. And we use various of electrical automation and lighting systems, equipments. And at last, we try to control and have a flow of natural daylight homogeneously. So far, I have shared some technical details, but at the end of the day, what we designed, what we intended to do is to create multiple architectural experiences. The first experience begins outside with its highly reflective facade. We aimed for the building to communicate with the vast emptiness around it. The building changes its color and sense of scale at different times, different weathers, different seasons. It almost blends with nature. We try to create a dialogue with the sky and even the ground. On the other hand, of course, we also needed a clear visibility from inside to the outside. So to achieve this, we created a code to distribute 4 different types of perforated panels. And each panel's placement is determined by interior function and also, of course, the sun orientation. And all this work was to determine the most efficient single position for each panel. This image is from our actual construction drawings. We have placed 7,200 panels and sent them to site. And as you can see, by the day, the facade seems really solid. But at night, its true transparency becomes visible. Inside, it's a completely different experience. This space is designed to restore the sense of scale lost in the vast emptiness outside. It is created at a human scale for people, blending technology, nature, and human experience. It serves as both an welcoming venue and also an efficient office. And the story ends on the rooftop terrace, where visitors can enjoy a stunning view of the entire plant. So the building opened in September 2023 and has been in use for over a year now. And so far it has received many visitors from across Turkey, including high school and university students, exploring green energy and, of course, architecture. In June, it even hosted the United Nations Habitat Organization with the panel named Sustainable Future. So with this project, we try to craft a space that speaks to the challenges of our time. One that not only serves its purpose, but also changes into an architectural experience. We aim to highlight the vital role of green energy, bringing attention to the need for responsible forward-thinking design and emphasizing a commitment to a sustainable future with the power of architecture. Thank you.
I saw some coded diagrams regarding the facade.
Yeah.
So was this generated using a software, the parameters to how that facade would be and what the various different squares are?
Let me just come back. So for the visibility from inside, we need some different perforations, of course. And we didn't want to make it homogeneously. So we have different types of transparencies between a 100% solid panel and also a 33% solid panel. So what we did is actually we tried to write a code to distribute these panels into the facades of this building, relating. Sorry.
Yeah, that's the code.
Yeah. Relating the interior use. I mean, we don't need the same transparency, of course, in the north facade than the west facade. Or neither we don't need the same transparency as the meeting rooms, also in the multipurpose room or in the foyer. Or we don't need the same transparency level in this eye level. I mean, in let's say in vertical, it could change. So all these parameters are integrated in this code, and we try to manipulate, distribute, and control the transparency levels with the use of the human experience.
So because there are solar fields here,
Yeah.
so what is the temperature in this area?
In summertime, it's around 40-45 degrees with almost zero humidity.
So does the facade change in any way based on the orientation?
Of course. It's getting closer more to the west side, because the west west facade is the hottest one, and the most open facade is the north facade, as you can see in the red, the most red area, which is considered as these engineering rooms.
And what is the methodology by which this facade turns transparent? Is it always glass and transparent, the transparent part, or is it some material that changes from solid to semi-transparent to completely transparent? What is the material of this transparency?
Actually, we have double facade. The first and main facade is the glass facade. Is a very transparent, without any protection, a basic facade. And the secondary facade consists of stainless steel panels, which we can achieve open air between them and have a breeze between the two facades, so that it cools down and gets the hot air in between, and it could exit easily on top.
Thank you.
How adaptable are the spaces internally? Imagine 15 years from now, and you don't have very few working people there because it's all run by AI or robots.
Yeah.
How adaptable is the spaces then vis-a-vis your facade of stainless steel panels and the glass wall?
I mean, it's hard to imagine, of course. I mean, the time is changing, and of course, even now, there are only 30 people working in this building. So it's getting lesser in air. But on the other hand, it could show us, it could point us somewhere to visit, maybe. Or it changed it to an R&D development site.
Or even a school.
Or even a school, yeah.
Research center.
Why not?
Yeah, but I was just interested how adaptable all your stainless steel panels are. They removable easily?
It's easily removable. It's all modular because we already build it in some other city and take it site and hang them. So it's really adaptable. Even the walls interior, it's almost like basic plasterboard walls, something like that.
Thank you.
Can you tell us a little bit the story of this place, of this, was a lake? Because they have something to do with the climate change or something else?
Exactly, because of the climate changes, as we know in the calculations in the last 20-30 years, the climate rised up. And also there is a very intensive agriculture there, there used to be, actually, and the groundwater levels are gone. And this is the north of this area is a very serious place because the ground starts to collapse down because of the lack of groundwater. So this place turned into a desert zone which loses its agricultural potential. And now they have a chance to regain this died land. I mean, in 1 year, we can easily observe that with the solar panels having shade underneath and also keeping the humidity underneath, you can easily see some greenery, some green bushes just came in again. And also a biodiversity just started to grow again. So I believe it will not be looking like this in the next 10 years.
It's like re-oasising, right?
Thank you.
It was very interesting, the idea there was using a lake.
Yeah.
I mean, disappear to
Yeah.
production energy and transforming this in a sort of a microclimate or reconverted this area into something else.
Yeah, yeah.
The building looks like a battery of all these panels. You know, it looks like
Yeah.
a battery.
Yeah.
But it was nice. It's a great project. Thank you.
Thank you. Thank you.